The hard disk drive has 5 main parts. A printed circuit board takes orders from the computer and controls the disk. An electric motor spins the hard drive's disk at exactly 7,200 revolutions per minute. The circuit board keeps the speed constant. And here's the crucial part, the actuator arms that hold the read-write heads. The ends of the arms are split, and right in the middle ride the disk platters. But the heads never actually touch the disks. The space between the head and the surface of the disk is 5,000 times thinner than a human hair. The heads float on a cushion of air created by the spinning disks. An absolutely essential cushion that prevents the head from crashing on the disk. And what a crash it would be. Talking about a crash is not only a metaphor. At these tiny scales, the weight of the heads really compares to the weight of a 747 airplane. A 747 airplane packed with 100,000 passengers, flying at 100 kilometers per hour, a fraction of a millimeter from the ground. Ouch. There's no friction to slow things down, so the arms can move the heads to write or access data up to 60 times per second. The engine that drives the arms is invisible because it's an electromagnetic system driven by 2 forces of nature, electricity and magnetism, which makes the arms move back and forth across the disk at lightning speed. That's it for the components. Now here comes the data. The data is stored inside tiny concentric tracks on the disk's surface. During manufacture, up to 200,000 of these tracks are created on the disk. Each track is divided into sectors. A map of the tracks and sectors in the printed circuit board tells the heads exactly where to read or write information. The surface of the disk is smooth and shiny, but look closer. It's way more complicated. A magnetic film on the surface memorizes all the information. The heads magnetize microscopic sections of the film and store the data in a sequence of ones or zeros. Each 1 or 0 is called a bit. The value of each bit is determined by the orientation of its magnetic field, plus or minus. And it doesn't take long for the bits to add up. One high-quality photo can take up 29 million bits spread across 12 different sectors of the disk. This sounds incredibly massive, but in reality, a